Hello everyone. So today we will talk about the story of circle. Basically we will be talking about how to find out the perimeter of the circle and the area. Though I have told you already the perimeter, but still I will again discuss it, and then we will come to very interesting derivation of our area. Okay, so that we can measure the area of the circle, and this thing you probably will not get in the book, but this thing is very interesting. Okay, so let's get started. So as we have told that there was a great mathematician Archimedes who discovered actually that if you measure the perimeter, that means the whole length of the boundary of a circle, and then if you measure the diameter of that circle, then the perimeter or the circumference, so the perimeter of the circle is called circumference. So this circumference, if we write this as c, because it's a big word and I cannot write this again and again, it's too tiring. So if you write this as c, so Archimedes has seen that c by the diameter of that this any kind of a circle is always a constant, and the value is 22/7. This value he has given the name of a pi. So pi is a number. It is actually a it's cannot be written in a proper fraction, so you cannot divide 22/7 okay easily. So this is a very unique number. So c by d, that means the circumference by d, is always 22/7. So this activity you can do in your home. You can draw any circle and then you can find out the this ratio, that is the c by d, to get and to see that whereas Archimedes was correct or not. Also, we know that diameter is the biggest chord of a circle, starting from one end to another end and going through the center of the circle. This diameter, if we divide into two parts, then each of this part is nothing but our radius. So we need two radiuses or two radii to, so the multiple radius are called radii. This is the plural form of radius. Okay, so if we have two radius, that will make a diameter. So we can write, instead of d, we can write 2r. So we can write that c by d, instead of d we can write twice r, because d is nothing but your twice r. So this is actually equal to pi. So from this we can easily get that c is equal to twice r pi, or you can say 2 pi r. So this is the formula for measuring the perimeter of any circle if you know the radius. Okay, so this was the previous classes topic. That means if you walk from this place and if you complete the walk throughout the circle, and if you come here again, then the total length that you will cover is this circumference c, which is your 2 pi r. Now this was the the method of measuring any perimeter of any circle. Now comes the interesting part, that is area. If I draw some objects, shapes like this, so this, we know that this is a square having all sides same. Does it look like a circle? Not really. Okay, so what I am going to do now, I am going to increase one extra side. So this is a pentagon. Does it looks like a circle? Not really. Okay, so I will draw now a hexagon. Does it looks like a circle? Kind of. So one by one, if I increase the number of shapes, so it will be like when the sides, so this is having 4 sides, this is having 5 sides, this is having 6 sides. So if I increase the number of sides like 10, 8, so I can see that. So if I just draw 8, that is an octagon. So if I just draw, I'm not good at drawing at all. So if I draw an octagon, so you can see that this octagon is little bit, it's looking like a circle. So you see that when we are increasing the number of sides that a polygon can have, then it is becoming like a circle. Okay, now so let us try to find out what is the area of this all of the shapes. So starting with pentagon, we can find out the area of pentagon. So the area of pentagon, or let us start with hexagon, that will be interesting, I think. So if we talk about hexagon, so this is a hexagon. So in this hexagon, I am assuming that all the sides are same. What I can do, I can divide this, I can join all of the opposite sides like this. So you can see inside I have different triangles, right? So in this triangle, it is not a, so if you see this inside one triangle, it is not a right angle triangle. So I cannot find out area of this right angle triangle because this is not a right angle triangle. But if I divide this thing into 2 portions, then I have 2 such triangle, right, in one big triangle. So this is one triangle which is right angle triangle, and this is another triangle which is also right angle triangle. So what is called a right angle triangle? A right angle triangle is a triangle which is having one 90-degree angle. So that means one right angle, it is having one right angle. Right angle means 90 degree. Okay, so we know that the area of any right angle is half into base. So let's say this is my base is A and this is B, so we can say that this is half into A into B. So this is the area of any right angle triangle. But when I divide this big triangle into 2 portions, so now it is having this one and it is having this one. So if I do the same for all of the sides, what are we getting? We are getting something like this. So we are getting how many triangles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I am getting here total 12 right angle triangles. So the area of this hexagon I can write as, so I can write the total area. So total area is equal to 12 right angle triangles. So triangles. So if I find out area of any one single triangle, and then if I multiply by 12, I will get the area of the total hexagon, right? Okay, so now let us do that. I don't know this length. This length I don't know. So I will take this length as L. Now if the total length is A, then half of that length will be a by 2. So I'm not writing here a, instead I'm writing a by 2 here and a by 2 here, because this is the half of the total length. So total one side is a, so half of it is a by 2 and a by 2. So let us find the area of this first triangle now. So which one? I'm talking about this triangle. So in that triangle, what is the area? So area is equal to half into base, that is your a by 2, into length, that is your L. So you can see that because this is a hexagon, so we are having 12 triangles. Hexagon is having hexagon is having 6 sides. So 6 sides into 2, because for each of this side we are having two triangles. So 2 triangles. So there we have 12 triangles. So the area is half into a into L. So this we will get a L by 4. So the total area of this all of the triangles will be a L by 4 into 12, and that will come 3AL, right? So that will come 3AL. So in this way, if we keep on increasing this thing, so you can see one thing clearly, that if I write this if I write this area, so that was our hexagon. There are, because for each of these we are getting two triangles, and each triangle is having this much, that is your AL by 4, right? Okay, so if I increase the polygon number, so if it was hexagon, now if I take octagon like this, so in the octagon, if we do the same, that is, if I just draw all of this diagonals, so how many we will have now? So these all sides are A and A. So in this small side, what we can do, we can again I can again divide this into 2 right triangles, and then I can measure the area. So there will be, so if I just divide this thing, so I will get all of the right triangles. So this time how many I am getting? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So you can see one thing clearly, in case of octagon I am getting, so total area again, this is a octagon, and that's why for each I am getting 2 into, so see, this was hexagon and I am getting 2, this is octagon and I am getting 2, and same way, if this length is L and this is a by 2 and this is also a by 2, if we divide it into 2 equal portion, so this will be again, so the inside area of one small like right angle triangle will be this much, and that will be how much? The same formula, so it will come same, AL by 4. Sorry, let it be in green only. So AL by 4. So you can see that when we will increase this, so this was 6 and the formula was same, and this is only 8 but the rest of the formula is same. So in this way, if we keep on increasing the number of sides, like decagon for 10 side and more, so what will happen? it is becoming like a circle. See, this is more circle or this is more circle? Obviously this is more circle, so it is becoming like circle. Now if you see one thing clearly, that what is the perimeter of this what you say, hexagon? The hexagon ka perimeter is, see, 1a, 2a, 3a, 4a, 5a, 6a. So there are 6 sides and all of the sides are having a. So a is the length. So that means the perimeter is 6 into a. So you can write this equation, this line you can write, this a you can put with 6. So this is 6a into 2 into L by 4. Okay, so I have put this a with 6. Fine, that I can do. In this case also, the perimeter of the octagon will be, total 8 sides are there, each side is a. So if I run and take one round, then how much I will run? I will run 8a, because each side is a and there are 8 sides. So this one also I can write as 8a into 2 into L into 4, L by 4. So you can see here clearly one thing, that this one is same. See, here also same and here also same. If you do it for 10, or like for decagon, if you do, that means having 10 sides. So according to our what you say, theory, it should come 10a into this part is same, that is 2 into L into 4. What is L? L is this distance, okay, from here to center to one of the side, and A is the side length. Okay, now for a circle, so in this case, one more thing to tell you, this is the then perimeter. So you have to multiply. So I am getting a formula. So we are actually discovering a formula. Okay, so this is really interesting. We are discovering a formula. So this is perimeter of the decagon. In this case, this is the perimeter of our octagon. This is the perimeter of our hexagon. So we can see that in all of this case, what is our formula we are getting? Perimeter into 2L by 4. So area of any such object, it will be your perimeter into 2L by 4. Okay, so now we are going to do this for a circle. Now for circle, this L is, we say, R. Yes or not? Like this, what we are taking L here and here, this thing, in case of our what you say, circle, we take as R, radius. So without L, I can write here radius. Or what I can do, I can, instead of writing L here, I can write these all as R. So I am doing, my God, okay, I am doing R here. So instead of writing, so that there will be no confusion. So this all I will make R here. This also I will make R. This is also I will make R. Also I will make R. So this is R, this is R, this is R, this is also R. So now you can see that now everything is coming like that. So that means for circle, the same formula will be, area will be perimeter. Acha, because I have written R everywhere, so this also will be R. So now the formula will be perimeter into 2R by 4. What is the perimeter of circle? We already know that the perimeter of the circle is nothing but our C equal to 2 pi R. So we will put this value here. We will use this value here. So I'll put 2 pi R into 2R by 4. if we do this, what we are getting? We are getting pi r square. So this is our famous formula for the area of the circle. So if I have the circle right here, so my area will be pi r square. So now I know how to find out area, that means the space inside the circle. So this is the space inside the circle. Okay. Acha. So that means what is r? R is the radius of the circle. So now I know all of the formula of a perimeter also, that is 2 pi r, and the area also, that is pi r square. And how we get it? We get it by using our brain. How? First we have seen that, okay, we have so much of polygons. If I have polygons with higher number of sides, they looks like little bit of circle. So more I increase the number of side, it becomes circle and circle, more like circle, more like circle. So what I have done, I have first found out what is the area of a hexagon. So we have seen that we can join the diagonals, we can create two right angle triangles using this big triangle. Why? Because we only know the area of right angle triangles, but we don't know area of normal triangle, right? So that's why I have made intentionally two right angles triangles like this. So once I have seen that in all of this case, in hexagon also this is coming, and in octagon also this is coming, whereas this portion is nothing but the perimeter. So in this case, this is the perimeter of hexagon, this is the perimeter of octagon. So if I do it for decagon, so it will come the perimeter of decagon into this portion. So this is constant, this one is same for all. See, for all this one is same. So for circle, if I keep on increasing the numbers like decagon, then 12 arms, then 14, then like that 100, 10,000, if I keep on increasing, so ultimately chance is there that I will get a circle like this. And then the area of the circle should be same, like this formula should be same as decagon, octagon, these all. So what is the formula will come? That first we have to multiply perimeter with this part, which is same for all of them. But we knew already what is the perimeter of circle, and we used that and we got the area of the circle. This is really interesting because this is kind of discovery, right? So I hope you have enjoyed this video, and please ask me anything if you have any doubt regarding the video. And thank you so much for staying in the class. So your question for the class will be that what is the area of a hexagon whose all sides are 5 centimeter. So you have to find out the area of the hexagon whose all sides are 5 centimeter, and I cannot write here, and your in that case what we have taken r, this r का value is you take this r ka value as r only. Okay, so it will come with r, the answer will come with r. Okay, so you don't have to find out r, you just have to write that as that expression with r. Okay, so the answer the value r will be there. Okay, so this is the class for today, and I hope you liked it, and please do ask me. I will see you in my next video. Okay, sayonara.